For today's video, I will be discussing to you all about the chapter 13, and it deals with WLAN configuration. So first, some of us remember getting the internet using a dial-up. Dial-up, it means that involved using your landline phone. Your landline phone was unavailable to make or receive calls while you were on the internet. Your dial-up connecting to the internet was very slow. It basically meant that for most people, your computer was always in one place in your home or school. So I know that every one of us are very familiar when it comes to dial-up. Dial-up, it means that we are using our cell phones, landline phones, and such. So and now we are proceed to the um, some including in the chapter 13. So we have the module objective in that is implement a WLAN using a wireless router and WLC. So the topic title are remote site WLAN configuration, configure a basic WLAN on the WLC, and then the configure a basic WLAN on the WLC, configure a WPA2 enterprise WLAN on the WLC, and the troubleshoot WLAN issues. So later on, we will be discussing that each topic objective. So we are now in video configure a wireless network. So it has the wireless router. So I know that we are familiar with the wireless and the routers. It means that wireless is, for example, our um, something that we are using in our home or in our house, like in our or even in the company. And then the router is are using when we are um, making a topology in the packet tracer. So remote workers, small branch offices, and home networks often use a small space and home router. So these routers are sometimes called an integrated router because they typically include a switch for wireless clients, a port for an internet connection, and sometimes it labeled the WAN and wireless components for wireless clients access as shown for the Cisco Meraki MX64W in the figure. So this is our Cisco Meraki MX64W. I know that some of us are very familiar when it comes to this Meraki MX64W. So we also have the what we call the topology. So that is the for example the client or the person, and then we have the router and the switch, and then it can cause the internet. So basic network setup. So first step would be log into the router from a web browser. So the second one is change the default administrative password, and then the third log in with the new administrative password. Change the default DHCP IPv4 addresses to renew the IP address. Log into the router with the new IP address. So and then we have the configure a wireless mesh network. So in a small office or home network, one wireless router may suffice to provide wireless access to all the clients. However, if you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add the wireless access point. So, and now we are here in NAT or not for IPv4. So on a wireless router, if you look for a page like the status page, so here in the figure, so it means that you will find the IPv4 address information at the router uses to send a data to the internet. Notice that the IPv4 address is 209.165.201.11. So in some making a topology, I've been used most basically or usually the 192.168.168.1.2 for the IP address, but here we are using for the IPv4 address, so it means that it is 209.165.201.11. It's a different network than the 10.10.10.1 address assigned to the router's LAN interface, and all the devices on the router's LAN will get assigned addresses with the 10.10.10.1 prefix. So we have the quality of service. So in many wireless routers have any option for configuring quality of service or the QS. By configuring the QS, you can guarantee that certain traffic types such as voice and video are prioritized over traffic that is not as time sensitive such as email and web browsing. On some wireless routers, traffic can also be prioritized on specific ports. So here is the port forwarding. So wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. So it means, however, there are situations where specific ports must be open so that certain programs and applications can communicate with the devices on different networks. So when traffic reaches the router determines if the traffic should be forwarded to a certain or specific device based on the port number found with the traffic. So, and then we have the what we call configure a basic WLAN on the WLC. So, in the previous topic, you learned about your remote site WLAN configuration. So this topic is all about the configure a basic WLAN on a WLC. So WLC topology means that the topology and addressing scheme used for the videos in this topic are shown in the figure in the table. So the access point or AP is a controller based AP as opposed to an autonomous AP. And then recall that controller-based APs require no initial configuration and are often called lightweight APs. So this is our topology. So we have two PCs, the PCA and the PCB, and we have in PCA it has the router. However, in PCB it has the switch, and then our AP1. So AP is PoE, or which means it is powered over the Ethernet cable that is attached to the switch. So we have the addressing table, and I know that we all of us are knows about the addressing table. Our device, the device name, which is the router, switch, the WLC AP, and then our pieces, and then our interface is the fast Ethernet. And then our IP address like 192.168.1.2, like the IPv4 and IPv6 addresses. And then our subnet bus is always 255.255.255.0. So to log in into the WLC, configuring a wireless LAN controller is not that much different from configuring a wireless router. So the big difference is that the WLC controls a EPS and provides more services and management capabilities, so many of which are beyond the scope of this module. So we have the view AP information. So when we are click the access points from the left menu to view an overall picture of the AP system information and performance as shown in this next video. So we have the AP is using IP address 192.168.200.3. And then configure a WLAN. Wireless LAN controllers have ports and interfaces. Ports are the sockets for the physical connections to the wired network. So it means that they assemble switch ports. Interfaces are virtual. And then we have to configure a WPA to enterprise WLAN on the WLC. So It has a video, and then the SNMP and the radius. So in the figure, PCA is running Simple Network Management Protocol, or the SNMP, and remote authentication dial in user, or the radius, server software. So when we say SNP is used to monitor the network, and the network administrator wants the WLC to forward all SNMP log messages called the traps to the SNMP server. So we have the configure SNMP server information. So this is the example. So like the management SNMP, the trap is receivers. So so we also have the troubleshooting when the network is slow. So we have the what we call the increase the bandwidth of 802.11 dual band routers and APs either. So the upgrade your wireless clients, the split the traffic. This is the example of split the traffic. So we have this. So home net 5. So we have the PC, the TV, and even TV. So they are connected to the in that center. So later on I will be summarizing about this chapter 13.